Hello class 10 students. What if I ask you to stand in front of the plane mirror? What you will observe? Your answer will be very simple. Sir, image will be obtained. But what you are not going to obtain, that is the kind of fear you are having for your board examination, because physics seems tough for you. So don't worry students. Physics Wallah, that is the most trusted education platform, bought you a 10th board booster for you. That is a free crash course. So in this very first chapter, that is light, reflection and refraction, I will be covering every single corner. That is reflection of light, its laws, reflection through plane mirror, reflection through spherical mirrors, refraction of light, refraction through spherical lenses, power of a lens and power of combination. These are the major topics which has been asked in the previous year questions. So I will be covering all the concepts along with the numericals as well as the previous year questions which are actually required for you. So me, your physics captain Vikas Sir will be providing you all the lectures of physics of class 10, and to watch all the lectures you have to go to the PW Foundation English channel. And to get class notes, DPP, practice sheet, what you have to do, you have to click on the link given in the description box, which will redirect you to the PW application you have to enroll for the free batches. Apart from that, you will be getting class notes, DPP, practice sheets, so that you can ensure your preparation is 100% perfect before the board examination. And this is my guarantee, and I am count on my words, student. You have to put complete faith what I'm going to teach. You have to observe everything, you have to learn all the concept, practice everything, and you will be an achiever. So let's start. So today we will be taking your first lecture of physics, that is light. Light comprises of two different categories, that is reflection of light and refraction of light. You know what, the many students are getting confused. Sir, there are too many numericals are there. So there are too many rules, there are formation of images. I have a plan for you so that you can make it more easier. I'll try to explain each and every single thing according to what I just said to you. In that manner, it will be quite convenient for you to understand the concept. So what exactly I have, so the topics that we are going to cover, that will be in a proper sequence. That is reflection of light, then we will discuss about spherical mirrors, then sign conventions, then rules and formation of images by spherical mirrors. You need to put more concentration in that particular part. And refraction of light, then spherical lenses, rules and formation for the spherical of lenses, and power of the lens. This is how in 8 different parts we will be covering the entire chapter. So let's begin. So the introduction says what is light. The very first thing or a 1 marker question appears from that, like what is light. So we need to understand the light is a form of energy. It is nothing but a form of energy which helps us to see things around us. See, without light you won't be able to see anything. It will be a complete dark. So in the presence of light we are able to see. So it is a form of energy through which you are able to see, or it gives the sensation of vision. So that's how you do that. And the speed of light in vacuum, that is 3 times 10 to the power 8 meter per second. So that is the speed of light which we are going to use at various places. So you need to remember this value. Sometimes people, the students are asking, sir, what is the speed of light in air? So it is approximately 3 times 10 to the power 8, because there is a presence of particles or a medium, that is air medium. So speed gets a bit lower side as compared to the vacuum, but approximately we consider it as 3 times 10 to the power 8 meter per second. How the light travels? So the light travels in a straight line. So it always travels in a straight line. So whenever we are going to draw the ray of light or the beam, it will always travel in a straight path. Apart from that, from where the light is going to come? So we know about the sun, bulb, light. So these are called sources. So the source of light is nothing but an object from which light is given out, maybe natural or maybe man-made. As I gave you example of sun, so that is a natural source of light. Bulb, light, these are the man-made sources of light. Apart from that, when we talk about the images, there are 2 kinds of images. What is that? The very first is real and inverted. We need to understand what is real and inverted. So it's quite easy. If the object is like that, the image will be appearing upside down. So that is called inverted image. That is called inverted image. If the object is like that, the upright, the image will be forming upside down. That is called the inverted image. What about the real? So in a real category, I would be writing which can be obtained on screen, which can be obtained on screen. So real images are those images which can be obtained on screen. The example is the movie theater, the movie which you generally watch in a theater. You see a projector which is projecting on a particular screen. That is called the real image, right? The projector you must have seen in your school. They must be showing some presentation or some video. So you are required a particular screen. Such images are called real images. Whereas there are other kind of image, that is virtual and erect. Virtual image which cannot be obtained on screen, which cannot be obtained on screen. Like example, let me tell you, when you are standing in front of the plane mirror, do you require any screen to see your image? No, never. You do not require any screen to see your image. What you see yourself inside the mirror, so you do not require any screen. So in that case, such particular images are called virtual images. What about the erect property? So when you are standing in front of the plane mirror, you are standing like that, the image will be exactly like that. So this is called inversion of the image. This is called erect image. So that is the difference between the real and inverted and virtual and erect. Sometimes the question, the student might ask, sir, can a virtual image can be inverted? Generally, no, no, no. Virtual image will be erect and real image will be inverted. The next thing is, what is a medium? Because the light is traveling through various mediums. So what is a medium? So medium is a substance through which light propagates, through which the light travels. Reflection of light, so that is one of the phenomena which we generally observe in our daily life. So reflection is nothing but it is the bouncing back of light in the same medium on striking the surface of any object. You must have seen the plane mirror. Let's take an example for the plane mirror. So that is the plane mirror. Consider it as plane mirror. I'm doing the polishing on the right side. So now it became a plane mirror. So if here we have a medium, so let's suppose this is the medium and light is striking on the plane mirror, it will reflect back in the same medium. This is what the reflection of light is. The bouncing back of light in the same medium is called reflection of light on striking on any surface, be it plane mirror or spherical mirror or any other surface. So this is what the reflection of light is. What kind of different reflections are there? So there are two kinds of reflection. One is regular reflection and second is irregular or diffused reflection. Irregular reflection can also be called as diffused reflection. So regular reflection is what? So regular reflection says when the reflecting surface is smooth like plane mirror and well polished again like plane mirror, the parallel rays falling on it are reflected parallel to one another. If I draw the another ray of light parallel to this ray, after reflection it will be reflecting back parallel to the reflected ray. So you can see this is what the regular reflection is. So understand the concept. When the rays of light is striking on any surface after reflection, it is going again parallel in the same medium. That is called the regular reflection. Whereas the irregular reflection will be exactly opposite to that. Like if the rays of light are coming parallel to each other, striking on surface, going in the various diffused direction, that is called the irregular, or it can also be called as diffused reflection. See, we are able to see different objects like your wall, ceiling, floor. They are not perfectly reflecting material, but we are able to see them because they are actually doing the irregular or diffused reflection. The reason is there is no polish, no shiny surface. So when the light is striking on it, it is having some sort of diffused surface. So the light diffused in the various direction and we are able to see the object. So such reflections are called diffused reflection. Let's take an example. So we are having the different categories over here of the regular reflection and irregular reflection. So let's see, the rays of light are coming parallel to each other and I'm drawing the normal. This is what the normal, perpendicular to the surface is a normal. So if you observe, all the light rays are going parallel after reflection, whereas in the diffused reflection, if you see, the light is going in the various direction, like that, like that. So this is the difference between regular and irregular reflection. Moving ahead, so what are the laws of reflection? One of the favorite questions, or the analytical based questions which is appearing in the previous years, based on such diagram, which is the explanation of law of reflection. So according to the laws of reflection, we have two different kind of laws. The very first law says the angle of incidence is equal to the angle of reflection. Amazingly, what are the notations? So the light which is actually incidenting, we need to understand this. If the ray of light is incidenting on the plane mirror, that is called the incident ray, whereas the light which is going back, that is called the reflected ray, and the angle formed between incident ray and normal, that is called the angle of incidence, and the angle found between reflected ray and normal is called angle of reflection. And this is my normal. Normal is nothing but perpendicular, an imaginary perpendicular to any surface at any point. So according to the law of reflection, it says the angle of incidence will be equal to the angle of reflection. They will be equal to each other always and always, be it for the regular reflection, be it for the irregular reflection, be it for the spherical mirrors. It is applicable everywhere. The second point is the incident ray, reflected ray, normal all lie on the same plane at the point of incidence. So this is the point of incident. So they all lie on the same plane at the point of incidence. Most important question, 2 marker, sometimes in an analytical question 4 marker. So just memorize it. Law of reflection will be applicable everywhere. It is a law, not a rule for anything. So law will be applicable everywhere. Moving ahead, so the reflection of light in this category, like what are the exact characteristics which we generally see in the plane mirror? When we see the images in the plane mirror, what we observe? The very first thing that we observed, which is the image of a real object is always virtual. So the images formed by the plane mirror will be virtual and it cannot be obtained on screen. It cannot be obtained on screen and it will be a virtual image. I already gave you the insight about the virtual and direct image, and this is what we are going to get in the plane mirror. So this is the very first point that we have covered. The next point, the image formed in the plane mirror is always erect. So if you are standing upside right, it will give you the same image. Your head will be up as the object. So it will give you always an erect image, like the upside of the image is the upside of the object. This is how you get the image in the plane mirror. The size of the image in the plane mirror is always the same as the size of the image, which means whatever your height is, whatever the size of the object is, the image will be also of the exact same size when you are obtaining the images in the plane mirror. That is point number 3. So 1, it gives a virtual image. 2, it gives an erect image. 3, the size of the image is equal to the size of the object. So these are the 3 points which we have seen so far. The other 2 points are the image formed in the plane mirror is as far behind the mirror. That means if this is your plane mirror, if the object is here, the image will be exactly on the other side at the same distance from the plane mirror. If you need to observe this, so this is how you see yourself. Like for an example, if this is my plane mirror and I'm drawing an object here, you will be getting the image exactly opposite. The distance between the plane mirror and the object and the distance between the plane mirror and the image will be equal to each other. If they are standing d distance apart, the distance of the object from the plane mirror will be equal to the distance of image from the plane mirror will be equal to each other. Point number 5. The image formed in the plane mirror is laterally inverted. You must have noticed that when you are standing in front of the plane mirror and observing your image, if you are taking your right hand up, it seems like in the image you are taking your left hand up. So that is called the lateral inversion. If you see the image of the boy, he is already taking his right hand up. So in the image it appears like he is raising his left hand in the upward direction. So that is called the lateral inversion. It is not inverted image, it is called lateral inversion. So these are the major 5 characteristics what we usually obtain when the image is formed in the plane mirror. The first was virtual, second erect, same size as the object, same distance from the plane mirror of the image, and the last is lateral inversion. This is how you get the 5 characteristics of the formation of images in the plane mirror. Talking about spherical mirrors. Now from here, the thing is going to be complicated for you. We'll keep it sorted. You just only need to understand the concept. Mind my words. Whatever I'm saying, I'll make it quite easier for you and things will be sorted for you. Just listen carefully what I'm going to say in next half an hour. So spherical mirrors, just imagine you have a complete sphere right in front of you like that. Whatever is given in the diagram, you have a complete hollow sphere and you just given a small cut and you get a small bowl kind of thing like that. That is the spherical mirror. So I have taken a sphere which must be having a center in the middle of the sphere. I have taken a part out of it. I have gotten this kind of image or the figure, I can say. Now just listen to this carefully. There are 2 different diagrams which you can see right here. The very first one is this, second one is this. Here the polished surface you can see on the right side, whereas the polish you can see on the left side. So this is how we get the 2 different kind of spherical mirrors. But what are the names of the spherical mirrors? So one is the concave mirror, other one is convex mirror, but we need to identify which one is concave and which one is convex. So talking about the spherical mirrors, I'm giving you a very easy method to remember which one is concave mirror and which one is convex mirror. This is my hand, consider it as a spherical mirror. If I'm going to polish the outer surface and the reflection taken from the cave side, I'm repeating, if the polish is done on the other side and the reflection is taken from the cave side, then it is called a concave mirror. On the opposite hand, if I am going to polish the cave side and the reflection taken from the burst outward part, that is called the convex mirror. This is how you can remember which one is concave, which one is convex. Go to the previous image. Now you can see the reflection is going to take place from the cave part. So this particular mirror is nothing but concave mirror, whereas the cave part is polished and the reflection will be taken from the bulged outward part. That is called the convex mirror. I hope you understand what exactly I am going to say. So if you understand this, we need to understand what are the major points or terminologies we need to remember to understand the concept of spherical mirrors and the formation of images by the spherical mirrors. So consider we have these 2 mirrors right in front of me. One is concave mirror, other is convex mirror. There are certain points which I am going to mention. The very first one, this point, that is called pole, represented by P. That is called pole, represented by P. That is the midpoint of the spherical mirror, whatever you are going to take, be it convex or concave. So the middle point of the spherical mirror, that is called pole. We have the center of curvature. So what does that mean? Center of curvature is the center of that sphere of which this mirror is a part. So you have taken a sphere, you have taken out this spherical mirror. That sphere was having a center, that is a imaginary center that we are considering, of which it was a part. That is called the center of curvature for both the mirrors, represented by capital C. Now, if we have an imaginary line passing through pole and center of curvature, I'm having an imaginary line passing through pole and center of curvature, that is called principal axis. So three things we have covered so far. One is pole, second is center of curvature, and the principal axis. Principal axis is an imaginary line passing through pole and center of curvature. The distance between, see, all the distances will be measured from pole. That is one of the rule. The distance between pole and center of curvature, that is called radius of curvature, represented by capital R. Represented by capital R. It is the distance between pole and center of curvature for both the mirrors. Just make a note of it. I am going a step ahead to make you understand like what is the definition. So for pole, the center of the spherical surface of the mirror, this is what I told, the center of the spherical surface of the mirror. Center of curvature is the of which the mirror is a part. The center of the spherical shell of which mirror is a part, it lies outside the surface of the mirror. You must have observed the mirror was placed like that and the center was outside the mirror. That is called the center of curvature, represented by capital C. Principal axis is an imaginary straight line joining the pole of the mirror and center of curvature. Principal focus. You guys need to focus. Principal focus is the point on the principal axis of the mirror such that rays incident on the mirror parallel to the principal axis. If the rays of light coming parallel to the principal axis, after reflection, they meet or appear to meet at this point. So we need to understand what does that mean, like meet or appear to meet, in few minutes. Radius of curvature will be the distance between the pole and the center of curvature. This is what the radius of curvature is, talking about the focal length. See, generally the focal length appears exact between the pole and the center of curvature, but the distance between pole and focus will be called as focal length. The focal length is the distance between pole and principal focus of the mirror, that is called the focal length. And we have the aperture. Aperture gives the size of the mirror. It gives the size of the mirror. So I have taken like this much size of the concave mirror, for example. So this is called, moving ahead, talking about the principal axis, how we need to define or how we exactly are going to define the principal axis. So for that I need to make few points, that is pole, that is center of curvature. I need to draw principal axis, which is the imaginary line passing through the pole and center of curvature, as I mentioned. So for example, if the rays of light coming parallel to the principal axis, after reflection, what is going to be happen? Listen to this. If you are having a plane mirror or a plane wall, if you are throwing a ball right in front of the plane surface, after striking it will be coming back straight. You know that. What if the surface is like that? So if the ball is going to strike at such surface, it is going to come down, and at the bottom it is going to come up. Same is going to be happen with the light rays. So after reflection, this ray of light will be coming down and this ray of light will be going like that, and this point that we have obtained, that is called focus, and the distance between focus and pole will be considered as focal length, represented by small f. So we need to make this difference very clear. Principal focus, when we are defining the point, you need to write it as capital F. When you are measuring the distance between the pole and focal length, it will be a small f, that is focal length. Got it? So this is principal focus, this is focal length. Talking about the convex mirror, so we have pole, the curve is on the right side, so the curvature or the center of curvature will be also on the right hand side. So if I draw the principal axis and the rays of light coming parallel to the principal axis, now that is an interesting case. As I gave you an example, you are throwing a ball in front of the plane mirror or the concave mirror. Let's do the same activity with the convex mirror. So if the surface is like that, you will observe that the rays will be diverging like that. The rays are diverging. After striking on the mirror, they will diverge in that direction, and it has been said that they will appear to meet. They are actually not going to meet, you know, for by the end of the time they are not going to meet, but they will appear to meet at this point, and this point is called principal focus for the convex mirror, and the distance between pole and principal focus will be again represented by small f. The most interesting and most frequently asked question in the board examination. Moving ahead, like express the relation between focal length and radius of curvature of spherical mirror. They're asking about the relation, like what is the difference between radius of curvature and focal length. So the relation is quite easy. The radius of curvature is twice of focal length, or focal length is equal to half of the radius of curvature. That is the relation between focal length and radius of curvature. I hope you got it. Now, rules for the formation of images, very, 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 very important, because the numericals which you need to solve, it's not only by mathematics. You need to understand how the rays are coming, where the image will form, what kind of nature it is going to give. So before forming the images, you need to understand the rules. It is exactly like when you are driving a car, you need to understand the traffic rules. This is how we are going to understand the rules for the formation of images. The very first rule says the incident ray parallel to the principal axis actually passes or appear to pass through the focus. Yes. In the previous slide, just we have seen when the rays of light was passing parallel to the principal axis, it was actually meeting at focus when we have seen in the concave mirror, and it was appearing to pass through focus when we are looking into the convex category. So that is the very first rule. Second rule, incident ray through the center of curvature falls normally and reflected back along the same path. When the ray of light, when it is incidenting or appear to passing through the center of curvature, like for example, if I draw this, so that is the principal axis, and I'm mentioning this is my center of curvature, this is pole, and if a ray of light passing through the center of curvature, it will be coming back along the same path. No changes required, because it was already passing through the center of that sphere of which the mirror was part. Same is going to be happen with the convex mirror. So that is the convex mirror. This is pole, this is center of curvature, the principal axis, this is the principal axis, and the rays of light coming parallel to principal axis. The rays of light passing through center of curvature, it is exactly not going to do that. So we need to appear to pass through the center of curvature. So it seems like it is passing through the center of curvature. So after reflection, it will be following the same path. So whatever light is going through the center of curvature, it will follow the same path after reflection. Point number 3. So look at this. The same thing is given, like rays of light coming parallel, passing through the focus, and for the center of curvature, it will be passing through the center of curvature only. Point number 3 or rule number 3, if a ray of light incident through the focus is reflected parallel to the principal axis, it is exactly opposite to the rule number 1, where the rays of light was coming parallel to the principal axis, passing through focus. On the opposite end, if the rays of light passing through the focus, it will be going back parallel to the principal axis. That is our rule number 3. So look at this image. If the rays of light passing through the focus, it will be going back parallel to the principal axis. In the convex, if the ray of light appears to pass through focus, it will be going back parallel to the principal axis. That is rule number 3. And the last rule says, if the ray of light incidenting towards the pole by making some angle is reflected back on the same side by making the same angle. For this, we need to understand this. Pole. On which mirror? Concave mirror. The ray of light will be going back by forming the same angle, which means again angle I equal to angle R, which is happening in the previous cases also. But here we can clearly see that it will be making same angle, same as with the convex. So if the ray of light incidenting on pole, it will be forming the same angle, and that will be equal to each other. Angle I equal to angle R. So these are the 4 rules. I'm again going to repeat what are the 4 rules which we have seen just now. The very first rule, if the ray of light passing through principal axis, it will be passing through focus. If the ray of light passing through center of curvature, it will be reflecting back along the same path. If the ray of light passing through focus, it will be going parallel to the principal axis. And the rule number 4, if the ray of light incidenting on pole, it will reflect back along the same medium by making or by forming the same angle. Moving ahead to the formation of images. In concave mirror, we have 6 different cases, whereas in convex, you will be surprised that we have only 2 cases. That 8 cases we need to understand how this is going to be happen. Rule number or the formation number 1, which says when the object is placed at infinity. So we need to understand where the object is being placed. So we are considering this is my spherical mirror, and the object according to the size, the very far away, that will be considered as infinity, and the light rays which are coming through the infinity will be almost parallel to the principal axis, which you can see right away right here. So these are the light rays which are coming parallel to the principal axis. Such light rays, after reflection, it will be passing through focus. That is the rule number 1 that we know. If the rays of light coming parallel to the principal axis, they will meet at focus. So that is also applicable for the formation of image when the object is placed at infinity. Now, what kind of other things that we are going to get? So the object is at infinity, image that we obtained at focus. If we talk about the size, it seems like point sized, and nature of image will be real and inverted. Remember, when I explained about the 2 types of images, it is one of them. So the light rays will cross each other. So we are required a paper or a screen to get the image, and you will be getting a point image over here. So this is why it is a real and inverted image. That was formation number 1. Now I am going to shift the object a bit towards the mirror, and this is what it looks like when the object is placed beyond center of curvature. Initially it was very far. Now I have taken it to a considerable distance, but it is just beyond center of curvature, and we will be following the rules. According to the rules, if the rays of light going parallel to the principal axis, it will be passing through focus. Rule number 1, that's what we have seen. Rule number 2, if the rays of light passing through focus in the concave mirror after reflection, it will be going parallel to the principal axis. Yes, these are the 2 vice versa rules that we have seen, and now I can see the image or the reflected rays are meeting at this particular point, and at the same point the image is going to be formed. Here you can see the image is like that. So if the name of the object is like for example AB, the image will be A dash B dash. But sir, why this object is upside down? Because the nature of image is real and inverted. So again, object is beyond center of curvature, beyond center of curvature. So the image obtained between curvature, center of curvature and focus. Talking about its size, it will be comparatively smaller. It will be comparatively smaller. So I can write it as diminished for the smaller. I can use this term diminished, and nature will be real and inverted. Now again I need a screen to get this image. So that was the formation number 2. Now I am again going to take my object bit towards the center of curvature, and I have got the point that is the center of curvature itself. So if the object is at center of curvature, follow the rules that I have explained. So if the rays of light going parallel to the principal axis, the reflected ray will be passing through focus. So that is the incident ray. After reflection, it is passing through focus. Perfect. And again, the second rule, if the ray of light passing through focus, it will be going parallel to the principal axis, and I have got the image. Beautiful image. And what I have observed, I have seen that the image is forming on center of curvature itself. Yes, because there was a sphere of which the mirror was a part. If you are going to take the object at the center, the image will be exactly at the center. So you have obtained the image at the center of curvature itself. So that is a very, very interesting case. If the object is at center of curvature, image will be also at center of curvature. Talking about size, same as object. Advantage of being placed at the center of curvature. Nature, that is real and inverted, because again you required a screen to obtain the image. So that was formation number 3. Moving ahead to formation number 4. I have just taken my object at this place, naming it as AB, following the rules which says if the ray of light going parallel to the principal axis, it will be passing through focus, and if a ray of light passing through focus, after reflection it will be going parallel to the principal axis, and I have seen that the image formed beyond center of curvature at this point, and the name is A dash B dash. Interestingly, if you have noticed in the case number 2, where the image object was placed beyond center of curvature, image was between center of curvature and focus. Now when I am placing the object between center of curvature and focus, the image obtained beyond center of curvature. So if I am going to place object between C and F, the image will be formed beyond center of curvature. Talking about its size, if you have noticed, initially when the object was far, it was a point image. Beyond C, it was diminished. At center of curvature, it became same. Now the size of image is going to increase, and it will be a enlarged image in this case. And talking about the nature, nature will be real and inverted once again. Now that was formation number 4. Formation number 5. Now I have kept the object at focus. So that's my object. Now the rays of light passing through focus. Now these are the two light rays passing through focus, and if the rays of light passing through focus, it goes parallel to the principal axis after reflection. Yes, where they are going to meet? Nowhere, because these are the parallel rays. Parallel rays never intersect each other. They meet at infinity. Yes, you are right. They meet at infinity. So I'm going to write, if the object is at focus, the image will be at infinity. Size of the nature, that will be highly enlarged. Highly enlarged. And nature, to get the image of these light rays, you need real and inverted image. So on screen, when you will be obtaining the image of this, you will be getting a real and inverted image. Now these are the major 5 cases that we have seen so far: at infinity, beyond center of curvature, at center of curvature, between center of curvature and focus, at focus. Now the twist begins. Now I'm going to place my object between principal, focus and pole, and I will be obtaining something different. So let's do it. So I have taken this object, naming it as AB, following the rules, which says if the ray of light going parallel to the principal axis, after reflection it will be passing through focus, and if the ray of light passing through the center of curvature, it will be following the same path. So if you see, they are neither parallel nor meeting each other. They are almost like, some sort of diversion. So they are never going to meet, but they will appear to meet somewhere at the back, which gives the formation of image as virtual and erect image. So here we will be obtaining the image A dash B dash. So when you are putting your object between pole and focus, the image will be behind the mirror. Behind the mirror, as plane mirror, nature will be different. If you obtain the size of image, that will be enlarged. You will be getting a enlarged image. And talking about the nature, that will be virtual and erect this time. Virtual and direct. So there is only and only one case in the concave mirror where you will be obtaining virtual and erect image, and this is when you are putting your object between focus and pole. Got it? So these are the 6 formation of images by concave mirror. Before that, now there is a complete chart you can see. Have a look. Interesting to learn. Object at infinity, image at focus, highly diminished or point size, real and inverted. When you put beyond center of curvature, image will be between F and C, diminished, image will be real and inverted. If the object is at center of curvature, it will be forming at center of curvature, same size, real and inverted. Between focus and center of curvature, image will be beyond center of curvature. Now it is going to be enlarged, nature will remain real and inverted. Now the object at focus, it will be forming at infinity, highly enlarged, nature will be real and inverted. At the last case, when the object is between pole and focus, it will be behind the mirror, enlarged. Now the nature is virtual and erect. Moving ahead to the convex mirror. So there are 2 cases that we need to understand. First, when the object is at infinity, what is going to be happen? So let's consider the light rays are coming from infinity, from outside somewhere, like this. So what is going to be happen if the ray of light incidenting on pole, it will be reflecting back by forming the same angle. If the ray of light appearing to passing through pole, it will be reflecting back parallel to the principal axis. If the ray of light appear to pass through center of curvature, it will be reflecting back. And all this, what we have observed where at focus, where we have observed when the object is at infinity, image will be at focus. Talking about the size, that will be highly diminished or small, highly diminished, and nature here will be virtual and erect because it is forming inside or behind the mirror. So nature will be virtual and direct. Second and last case, if the object is placed anywhere between infinity and pole, what is going to be happen? So let's consider this is your object AB, naming it as AB. Following the rules, if the ray of light going parallel to the principal axis passing through focus or appear to pass through focus, as you can see it is passing through focus, appear to pass. Other one, if the ray of light appear to pass through center of curvature, it will be following back. Now here you can see the ray of light appear to pass through center of curvature. What I have seen, these appeared line incidenting at a point. Now this is the image A dash, B dash, and I will conclude like the object will be anywhere between infinity and pole. Image will be between pole and focus. Always it will be between pole and focus. Talking about size, always be diminished, and nature, that will always be virtual and erect. So these are the two cases. Let me tell you the uses of concave mirror and convex mirror. So the very first thing, uses of concave mirror. So testing of teeth by concave mirror. So generally dentists use it to see the larger image by using concave mirror, because when the object is placed between pole and focus, it will be forming virtual image, enlarged image. So this is how the teeth or the tooth cavity would be, enlarged. It will be visible to the dentist and that can be cured. Second, if you have seen the burning mirror where the concave kind of surface being used in a torchlight, in a solar cooker, you must have familiar with the solar cooker in from third, fourth grade, and the headlights of the car. Talking about convex mirror, so it has been used as a. So let's talk about the uses of convex mirror. So the uses of convex mirror, you must have seen the rear view mirror in various cars, two-wheelers, where generally it has been written like objects may appear while than they actually are. So it gives the smaller images and it gives protection to us so that we can see the vehicles are coming from back. So we can see that, and it gives a wider view because it generally gives the diminished images. Similarly, nearby your colony or maybe at the sharp turns or the U-turns, you must have seen this kind of mirror, which is actually a convex mirror, so that you can see the small images of the objects which is coming from the other end, and you would be able to identify and you will be feel safe. So that how to take turns. So this kind of mirror will be very useful. Moving ahead to the sign convention. What are the sign conventions required for solving the numericals or to understand the value? So remember, few points are there. So sign conventions for measuring distance from the convex and concave. First point, the very first point, that all the distances that we have done so far, all the distances will be measured from pole. All the distances, like whatever distance you need to take, radius of curvature, focal length, object distance, image distance, that will be considered from pole only. Second, the incident ray is taken from left to right. So wherever you are going to put your spherical mirror, concave or convex, the incident ray that we need to take from the left side only, be it concave, be it convex. So incident ray will be coming from left to right. That is point number 2. Point number 3, distances measured in the same direction as that of the incident ray can be taken as positive. If we are taking this direction as positive, and that is the direction of incident ray. So we will be taking this direction as positive from the pole, whereas opposite to that will be considered as negative. That was point number 3 and 4. So if you are taking this direction, consider it as positive direction. If you are taking this direction in that particular way, that will be considered as negative direction. Point number 5, distances measuring upward from the principal axis will be considered as positive. Like for suppose this is my principal axis, I have taken an object upright AB, and this will be considered as positive because this is in the positive y direction. Whereas if I get a real inverted image, that will be considered as negative because it is in the negative y axis. So this is how we need to learn. And another method to understand this concept, I am giving you the Cartesian coordinate system. That will be much more easier to understand what exactly we need to do. So to understand this, I am drawing the Cartesian coordinate system, and this point, what is this point called? In the Cartesian coordinate system, if you are considering this as positive x, this is negative x, positive y and negative y, what you consider this point? Origin. Okay, so I'm considering it as origin, but what exactly I'm going to say? I'm saying that consider origin as pole for your mirror. Like if you have concave mirror, the pole should coincide with origin. If you have a convex mirror, again the pole should coincide with your origin. Now you need to measure the distance. For example, I'm having a object on the left side because the incident ray will be going from left to right. So this distance will be on the negative x-axis, but the height of the object will be considered as positive because it is on the positive y-axis. If the image is formed on the right side, so if I need to take the distance, that will be on the right side on the positive x-axis from the origin or pole, so it will be considered as positive distance. But when the image is downward, which is going on the negative y-axis, it will be considered as negative. So these are the 5 points what we need to understand. First of all, the object will always be on the negative, so object distance will be negative. For real inverted image, so real images will be forming on the left side, so again the real inverted images will be considered as negative. For virtual erect images, which is generally going to be on the right side, so that will be considered on as positive. The height of the object will be considered as positive because it is already on the exactly parallel to the positive y-axis, and real inverted images, the height of the image will be considered as negative because it is parallel to the negative y-axis. That was the significance of sign convention, and by using this sign convention, I can guarantee you the numericals are never going to be incorrect. Use this sign convention, your numerical will be absolutely, you will be giving you, if you are providing the correct values, place the value along with the proper sign, you will be getting the correct answer for sure. Moving ahead to the mirror formula. From here the numericals are going to be appear, so just be ready for that. But before that, we need to learn the formula. The mirror formula says it is the relation between object distance, image distance and focal length, where u is the object distance. Object distance will be represented by u, image distance will be represented by v, and small f, we already know that this is nothing but focal length. So by using this, the relation between all three will be written as 1 by v plus 1 by u is equals to 1 by f. So that is important. Magnification. So that is applicable first of all for the concave and convex both. So don't need to worry. You do not need to remember the separate formulas for the concave mirror and convex mirror. Talking about the magnification. See, generally when I'm talking about the magnification, people says it is just going to magnify the image. It is exactly not like that. Magnification is the reference, or it gives the ratio or a kind of clarity to us whether the size of the image is being increased or decreased. So magnification, so that is the ratio of the height of image to the height of object, and also it is image distance by object distance with a negative sign. Image distance by object distance with a negative sign. So that is called the linear magnification. So that is the formula for the linear magnification. That is m equals to minus v by u equals to height of the image to the height of object. That's how you need to write it. There are few notes which I mentioned over here. Like if magnification value is 1, what does that mean? It means that the size of image and the size of object is equal, of course, and the image distance and the object distance are also equal. What if we have a virtual image? In that case, if magnification given as positive, that means for sure the image is virtual. But if the magnification given as the negative, be it any value, the image will be real and inverted. We just need to clear that in our mind. What does that mean? Like m is positive, that is virtual and direct. If m is negative, it will be real and inverted. Is that clear? Now we will be starting refraction. So what is the refraction? So just make the another segment of the refraction of light, and the refraction of light, as per the definition, it says the phenomena of change in the path of the light as it travels from one transparent medium to the other medium. So it is very easy to understand. If the ray of light is incidenting from one medium to another medium, it deviates its path or it changes its own direction. This is what the refraction is. So if you see, if I have a glass slab and the ray of light is coming from the air medium, it will be bending towards the normal. That is called refraction. Similarly, the ray of light which was traveling into the glass medium and entering into the air medium, it will be bending away from normal. In class 8th, you must have gone through with this refraction cases. The thing is, why all this refraction phenomena occur? The only reason is the refraction occur because there is a change in speed of light in the different medium. In air medium, generally the speed of light is quite higher, nearly to the speed of light in vacuum, that is 3 into 10 to the power 8 meter per second. Whereas in the other medium, be it water or glass, the speed of light goes decreasing because the particles are quite closer. As a result, the light ray becomes deviated, maybe towards the normal or away from normal, and this phenomena is called refraction of light. Let's talk about few other things. What are the causes? So if we talk about the basic concept, so the light is traveling from here to here. You must have observed there, if you take a glass filled with water and if you're inserting the pencil into it, you must have seen there is a slight bend in the pencil. It is because of the refraction of light. That is the only reason. How it happens, which I'm going to tell you like in few minutes. You need to wait. And moving ahead, what are the laws? We need to understand the laws of refraction. So in the reflection, there were two laws. Similarly, in the refraction of light, we again have two different laws. The very first law, which is equal to the second law what we had studied in reflection of light, that is the incident ray, refracted ray. I am repeating once again, refracted ray and normal all lie on the same plane at the point of incidence. Whereas second law says the ratio of sine of angle of incidence to the sine of angle of refraction is a constant. So this is giving us some trigonometrical term which clearly says that the sine of angle I by sine of angle R, that is nothing but constant. So if we divide these values, sin I upon sin R, we will get a constant. Let me give you a trick. This is going to give us the refractive index. Refractive index. What is refractive index? Many students are getting confused, like, sir, I'm having so many doubts in refractive index. So one by one we are going to discuss. But yes, there is one more formula for the refractive index, that is sin I upon sin R. But according to the Snell's law, sin I by sin R is constant, and this is what we are going to use in the coming slides. So if we see the refraction through a glass slab, what is going to be happen? So let's consider we have a glass slab PQRS and a ray of light AB is traveling from air medium and entering into the denser medium. So clearly I am saying the light is traveling from rarer medium entering into the denser medium, again entering into the rarer medium. This is how the light is going to travel. Correct? So when the light is traveling from air medium, when it enters into the denser medium, it bends towards the normal, and when it again enter into the air medium, it is moving away from normal, because the ray of light again coming back into the same medium from air to air, the light rays will become parallel. How I got to know? Let's have a look. If I extend the original incident ray, just like here I did, if I'm going to extend the original incident ray here, so I can see these two lines are parallel to each other, and these two parallel lines gives us some value that is called lateral displacement. What it is going to give us? Lateral shift or lateral displacement. Lateral displacement or lateral shift. According to the definition of lateral displacement or lateral shift, it says the perpendicular distance. Which distance? The perpendicular distance between emergent ray and original incident ray. Original incident ray. So if we take the perpendicular distance, if we measure it, you will get the perfect value of the lateral shift, and this is how we calculate the lateral shift value. I hope you got this. Let's talk about the few other terms which are required. That is, one, incident ray, you are familiar with. Refracted ray, you know that. But once the light is incidenting, refracting and again coming back into the same medium, the light ray becomes emergent ray, and the angle between them becomes angle of incidence, angle of refraction and angle of emergence. Amazingly, this angle and this angle will be equal to each other. We need to apply simple mathematics in that. If we see, this is forming alternate interior angle. So it has already been mentioned as R and R dash, but they will be equal to each other if it is a perfect rectangular glass slab. So this is how the refraction in a glass slab occurs. Moving ahead, so if you look into the absolute refractive index, so what does the absolute refractive index mean? Absolute refractive index define the ratio of speed of light as compared to the vacuum or air. So generally we consider it as vacuum because the speed of light is maximum in vacuum. So refractive index will be defined as the ratio of speed of light from vacuum to the medium. So let's consider the light is traveling from vacuum, entered into the medium. So what will be the refractive index in that case? So that will be the speed of light in vacuum to the speed of light in medium. That can also be written as like refractive index is equals to C by V. This is another way of writing the value of refractive index in short. That is absolute refractive index. What is the other kind of refractive index? That is called relative refractive index. So when a light is traveling from one medium to another instead of vacuum or air, so in that case we call it as a relative refractive index, because there are two different mediums having different densities and different refractive indexes. So in that case we call it as relative refractive index. So how we calculate the value? So the writing method, that is refractive index of 2 with respect to 1, that can be written as refractive index of 1 by refractive index of 2. That is the method number 1 of writing, or to get the value of refractive index of 2 with respect to 1, you need to write n1 by n2. But we studied, that is n1 means the refractive index of medium 1 with respect to vacuum. So we know the formula as per the absolute refractive index. that can be written as C by V1 and N2 can be written as C by V2. If I'm going to cancel out the value of C, I will be getting V2 by V1. So I have got the refractive index value as N1 by N2, or it can also be written as V2 by V1. So that is the formula for the relative refractive index. Apart from that, as per the notes, so you can write down a note point. So in the note point, what we have got, the refractive index can be written as C by V. Refractive index of 2 with respect to 1 can be written as N1 by N2, that is equal to V2 by V1. Refractive index can also be represented as sin I upon sin R. And one more thing, in case if the question being asked when there is a depth of water being given and they are asking about the apparent depth or real or apparent depth being given, you need to calculate the value of refractive index. In that case, the value of refractive index will be real depth by apparent depth. I will be giving you an example to make you understand how we can calculate the value of refractive index or the given real depth or apparent depth according to this. So this is the note point. You need to consider this in mind while solving numericals. That will fulfill your purpose completely. This is going to fulfill your purpose. Don't worry about that. So now some applications. So when you see the pencil, what exactly is going to happen? Let's have a look. So the pencil is completely straight like that. That is the pencil. But when we are looking from our eye, we see a straight line. So the light which is traveling from the bottom will be bending away from normal like that. This is going to bend, but because we see straight away, it seems that the bottom surface is going to be a little bit higher at this point. This is how the pencil seems a little bit, tilted or slightly bent. That is the only reason. One of the reasons why the base of the swimming pool appears to be higher. That is the reason. Correct? So water tank appears shallow and less deep than it's actually are. The only reason is the light which is traveling from the bottom point of the water tank, the light which is reaching to us, we are actually looking into the straight path. So it seems that the base image is going to be appear at this height. So at this height, so we feel that the base is quite higher when you are going for the swimming. You feel that okay, I'm able to swim in such depth. But once you are going to jump into it, you realize the water is too deep or the swimming pool is too at a great height or depth, and where I'm going to be drown inside it. So you need to be very careful when you look into any river, when you look into any swimming pool or water tank before jumping. If you want to analyze the correct depth of it, you need to watch, you need to see it very normally, because when the light is traveling straight away, no refraction will occur and you would be able to see actual depth of the water tank or swimming pool. So once you are looking from some angle, you won't be able to judge the actual depth of the water tank. What else? So now we are having few numericals based on the refractive index. So we are going to do that. Very interesting part. Students are confused in that. So don't worry, we will be solving every single numerical with the proper, the channel or the proper guidance of the board examination. This is what I'm going to give you again. So light travels through water with a speed of 2.25 into 10 to the power 8 meter per second. So the speed of light given, that is in water, given as 2.25 into 10 to the power 8 meter per second, and the speed of light in vacuum already given as, that is C is equals to 3 times 10 to the power 8 meter per second, and I need to calculate the refractive index of water. This is what I need to calculate. So we know the formula to get the answer. So refractive index of water with respect to vacuum, that is C by V. Yes, C by V. You need to write the answer in the comment if you get the answer before me. So refractive index of water, that is 3 times 10 to the power 8 over 2.25 2.25 times 10 to the power 8, 10 to the power 8, and this is going to cancel out, and on solving you will be getting the value of refractive index as 4 by 3, or if you want to keep it in decimal, then it will be 3 by 2.25. What will be the unit of refractive index? So there is no unit for the refractive index because the meter per second and meter per second will be going to cancel out each other. So there will be no unit for the refractive index. It is just a fraction by which the light is going to bend. So that was the, the kind of numerical asked on the basis of refractive index. What is the other kind? So the other kind is the light travels from rarer medium 1. So they clearly mention we have a medium 1 which is rarer, medium 2 which is denser. Of course, the angle of incidence and refraction are respectively given. So in the given data, I am going to write angle I given as 45 degrees, angle R given as 30 degrees. We need to calculate the refractive index of second medium with respect to the first medium. Okay, so you know the formula. In notes, I already gave you. So the refractive index of 2 with respect to 1, that is equals to sine I by sine R. Let's put the value. So this is going to be sine 45 degree. This is going to be sine 30 degree. The value of sine 45 is, correct, 1 by root 2. 1 by under root 2. And the value of sine 30 is 1 by 2 or root 3 by 2. Correct, 1 by 2. So this is going to be 2 by root 2. This can also be written as square root of 2 square root of 2 by square root of 2. And finally, the value of refractive index which I am going to get, that is under root 2, and 1.414 can also be written. The value of square root of 2. It's very easy to solve the numerical based on the refractive index. You only need to understand what exactly they are going to ask. What the refractive index with respect to what. Once you got to know, you will be able to crack every single numerical. What is the other type? So now the pond of depth 20 centimeter is filled with water. So now they have given us the depth of the water tank. So we are given with real depth, which is nothing but 20 centimeter, and the refractive index already given to us, that is given as 4 by 3. Up here they are asking for the apparent depth of the tank. Apparent depth, you can even consider it as no problem. So now for solving, the refractive index is equals to real depth by apparent depth. This is what I told you, right? Real depth by apparent depth. Let's put the value. So you will be getting 4 by 3. Real depth is 20. Apparent depth will remain as it is. So apparent depth will be equal to, let's do the cross multiplication, that is 20 by 3 by 4. On cancelling, I will be getting 5. And the value of apparent depth is nothing but 15 centimeter. Easy. So these are the kind of numerical generally in the refractive index they are going to ask. Now what? Let's talk about the spherical lens. What are the spherical lenses? What kind of spherical lens generally the board examination will be going to ask? So according to our syllabus, we are having 2 different categories of lenses. But how actually they are going to be made, or how they look like, so we need to understand this. So in the spherical mirror, we have considered only one spherical surface, whereas in this we are going to take 2 spherical surfaces. So if you see, there are 2 surfaces, and in this, if I am going to cut this much of portion, I will be getting 1 lens. Similarly, if I am going to place 2 different spheres in such a manner, this surface will be considered as the lens, which is of same material. Amazingly, for this particular surface, please be concentrated at this part. For this particular surface, this will be the center of curvature, and amazingly for the other part, this particular surface, C2 will be the center of curvature. So can I say that there will be two center of curvatures will be given for any spherical lens? The answer is yes, there will be two center of curvature, but exactly what we are going to consider. So we will be considering one primary center of curvature and another will be secondary. On the basis of sign convention and rules, we will be defining one of them. So just please be patient, wait for a while, you will be getting all the answers. Similarly, for this surface, this will be the center of curvature, and for this surface, this particular one will be the center of curvature. So in both the cases, you will be getting different center of curvatures. So let's have a look. So this is this kind of lens. If you are getting this kind of lens, this structure, that means the name of the lens is nothing but convex lens, whereas this lens is concave lens. How you would be able to identify? Generally in the viva or practicals, the examiner will be going to ask, how would you identify it is a convex lens or concave lens if you are blindfolded? So the answer is very simple. If you touch and feel it, it feels like it is thick in the middle and thin at the edges. That is also the definition of the convex lens. It is thick in the middle and thin at the edges, whereas concave lens is thin from the middle and thin at the edges. This is how you would be defining convex and concave lenses. We need to understand different terminologies based on the lens. So basic terms will be, first we have the aperture. So if I have the diagram, I have already drawn it. So if I have a diagram, so this particular dotted line, this diameter will be considered as the aperture. So aperture is nothing but the diameter of the circular edges of the lens. So this particular line will be considered as aperture. Very less asked question. What is the center of curvature? So center of these spheres are called center of curvatures. I have clearly mentioned earlier also in the previous slide that there will be two center of curvature, but we need to decide which one will be the primary one. Talking about the principal axis, so just imagine you are having one thing. Okay, one thing. This particular center will be considered as the optical center represented by O. In the spherical mirrors, we were having pole. In spherical lenses, we are having optical center, which is in the middle, exactly in the middle, somewhere in between the lens. That will be the optical center, and optical center is something from where if the light ray is going to incident, it won't be deviated. It will pass undeviated. The definition says that. So the principal axis, if I am going to make an imaginary line passing through both the center of curvatures and optical center, that will be your principal axis. So imaginary line passing through the center of curvature of the two surfaces is called principal axis of the lens, and optical center is a point on the principal axis of the lens such that the ray of light passing through it goes undeviated. That is the definition. So, and one of the rule that is going to help us, what is the principal focus for the lenses? So in case of this, in case of convex lens, if a ray of light coming parallel to the principal axis, it converges and meet at a point that is called focus. It converges and meet at a point that is called focus, and because this is going to converging, this lens is known as converging lens. This lens will be known as converging lens. Whereas if a ray of light is incidenting or appear to incident on focus, after refraction, it will be going parallel to the principal axis. This is how you would be able to find the point principal focus for both the lenses. Correct? Now, rules. What are the rules? Very, very important. So, rule number 1. If a ray of light coming parallel to the principal axis after incidenting on convex lens, it will be passing through focus. Yes, we know that. The light ray always passes through the focus when it is coming parallel to the principal axis. But the only thing is it need to be converged on the other side, because it is not reflection, it is refraction. So it will be going on the other side. This is how we need to define it, which clearly says that according to this, the focus will be on the right side of the convex lens And because the focus is on the right side, the primary center of curvature will also be on the right side of the lens. Got it? Point number 2. If a ray of light passing through the optical center, it will be going undeviated. So the straight line will be passing through it. Again the refraction occurs and the focus will be on the right side. Rule number 3. If a ray of light coming to the object and passing through the principal focus. So consider the ray of light passing through the first focus of the convex lens. After refraction, it will be going parallel to the principal axis. It is exactly like the rule number 1 that we have studied 2 slides back. Correct? So this is how it is going to pass. These are the major rules which are required to form the images, and we will be getting the complete image formations of the lenses. So let's begin. So for the concave lens, what are the rules? Okay, I need to mention the rules for the formation of images. So if a ray of light going parallel to the principal axis, it will be deviated. If it is going to deviated, that will be our diverging lens, as I mentioned earlier also. But it will appear to meet at a point that is called focus. So now, you need to put more concentration. The focus will become on the left side. If the focus is on the left side for the concave lens, the center of curvature will also be considered on the left side of the concave lens. So for the convex lens, the focal length will be on the right side, center of curvature will be on the right side, primary one. And for the concave lens, focal length or focus will be on the left side, as well as the center of curvature will also be on the left side of the lens. Next rule. So if a ray of light passing through the optical center, it will be going undeviated as shown like the previous one. So now the formation of images for the convex lens. One by one we are going to see. For the convex lens, we are having 6 different cases, same as the image formation we did in the concave mirror. The rules will be same, the formation of images will be same. Only the thing is the refraction is going to occur, and there will not be any reflection. There will be a complete reflection which you are going to see. So let's have a look. So if the rays of light coming parallel like that, so after refraction, it will form an image. It will be forming an image at focus. So now you can see here we have the A dash, B dash. So I'm going to write for the image. If the object is at infinity, the image will be at focus on the right side. Second, it will be highly diminished or point sized, and because the light rays are actually meeting, the nature will be real and inverted. I hope this is very loud and clear to you. I hope this is very loud and clear to you, right? Rule number 2. If when the object is beyond center of curvature, so I have kept the object just beyond 2f, object will always be kept on the left side. So I have kept the object AB just beyond center of curvature on the left side. So the rays of light passing after refraction, it will be passing through focus. So it is going like that. And the light ray which was passing through the optical center will be going undeviated. And we have observed we have got an image at this point A dash, B dash. I'm naming it as A dash, B dash, and I can clearly see that the image is formed between focal length and center of curvature. So I'm going to write about the image. When the object is beyond center of curvature, image will be between focus So if I'm going to write about the images, so image, point number 1, so when the object is beyond center of curvature, image will be between center of curvature and focus. Second, it will be diminished or smaller than the object. And talking about the nature, it will be real and inverted. So that was the rule number 2 for the formation of image. Moving ahead, if I'm going to, moving slightly, moving just at the center of curvature, what is going to be happen? So I've kept my object at center of curvature. I have just kept the object over here. What I'm going to get, let's follow the rule. If the ray of light going parallel to the principal axis, it will be passing through focus. Perfect. And if a ray of light passing through the optical center, it will be going undeviated. Again, perfect. Now I have got an image that is exactly at center of curvature, but on the other side. I have got the image, but on the other side, where at center of curvature. So let's talk about the image. So image will be at center of curvature on other side, not on the same side or right side, you can say. Second, the size of the image will be same size as object, exactly of the same size. And point number 3, the nature of the image will be real and inverted once again. That was the rule number 3. Now, if I need to move again slightly my object, now the place of the object will be between F and 2F on the left side. So I have kept my object at this point. Now I am going to follow the rules. And what are these? Parallel to the principal axis, passing through focus. And if a ray of light going through the optical center, it will be going undeviated. And finally, the image will be formed where? At this point. And this point seems beyond 2F on the other side. So let's talk about the image. So when the object is kept between F and 2F on the left side, image will be forming beyond center of curvature. The size will be enlarged. Now it is going to enlarge itself, and again the nature will be real and inverted. The reason is very simple, because the light rays are actually meeting. Case number 5. Now I am going to keep my object at focus. So I have kept the object at focus. So this is my object, and following the rules, so I can see that if the rays of light going parallel to the principal axis, it will be passing through focus, and the light ray which was passing through the optical center, it will be going undeviated. Amazingly, these two light rays, the two refracted rays, are not going to incident. They are parallel to each other, and we know this concept from the spherical mirror story. If the light rays are parallel to each other, they never meet. They will meet at, correct, at infinity. What will be the size of the image? That will be highly enlarged. Highly enlarged. What will be the nature of the image? Only a screen can obtain the image of it. So it will be real and inverted. And the last case, when the object will be placed between optical center and focus, and you know what is going to be happen. So if I am going to place the object here, I am going to follow the rules. So in that case, if the ray of light going parallel to the principal axis, it is passing through focus like that, and through the optical center it will be going like that. Now these two light rays are not parallel to each other. These two light rays are not parallel to each other. They are actually away from each other like that. They are not parallel. They are slightly away from each other. So I need to extend it back to get the value or to get the complete image. So I am going to extend it, and wherever they are going to slide, the image is going to be formed. So I can see that here I have obtained my image A dash B dash, which is on the same side, that is on the left side, because the image is formed due to appear to meet category. So that will be virtual and direct. So I'm going to write image form on same side as object, same side as object. Point number 2, size will be enlarged. Point number 3, The nature will be virtual and erect. Virtual and erect. This is what exactly happened. Almost, the image distance or the position of image, the nature of image, about the size. This is exactly we studied where in concave mirror, which is going to be happen in convex lens. So it will be quite easy if you know the concept of spherical mirrors. It will be quite easy to understand the concept of spherical lenses. But while reading numericals, you need to be very careful whether the question is given for the convex mirror or lens. So just be concentrate on that. Now talking about the concave lens, so we have taken if the object is taken at infinity. Let's consider the object is at infinity, so the light rays which was emerging from that particular object will be parallel to the principal axis. So it will be going like that, and after refraction it will be diverging because it is a diverging lens. So now you can see the light rays have been diverted. Now if the light rays have been diverted, they are never going to meet. In that case, I need to take it back and the image will appear at one point, and this is how we can calculate or evaluate the value of focus in the concave lens. We know that. So I'm going to write image will form, if the object is kept at infinity, image will be formed at focus, size will be point sized or highly diminished, you can write. Third, the nature will be virtual and erect. The last case for the formation of image of the spherical lens, in fact, that is the second formation for the concave lens, that when the object is kept anywhere between infinity and optical center. So I have kept my object at this point, that is AB. Now the light ray going parallel to the principal axis will be diverted like that, and the light ray which is passing through the optical center will be going undeviated. On emerging back, the light ray will be incidenting at this particular point. At this point, here the image will form. At this point, the image will be forming. So I can write it as image will form between optical center and focus. The size will be diminished and nature will be virtual and erect. Virtual and erect. That was too easy, right? Because you were already familiar with the spherical mirrors. Let's conclude it. So for the formation of image, we are talking about convex lens. So when the object is at infinity, image will be at focus, highly diminished, real inverted. Beyond 2f, image will be f and 2f, between f and 2f, diminished, real inverted. At center of curvature, image will be at center of curvature, same size, real inverted. Between focal length and center of curvature, image will be beyond 2f, magnified, real inverted. At focus, infinity, highly enlarged or highly magnified, real inverted. And between O and F, on the same side, magnified, virtual and direct. Same as for the concave lens. Object at infinity, image will be at focus, highly diminished, virtual and direct, and anywhere between optical center and infinity, image will be between optical center and focus, diminished, virtual and erect. So that was the end of the formation of images by the spherical lenses. Now we will talking about spherical lens and its formula and sign convention. Sign convention will be exactly same that you studied in the spherical mirrors. The only difference will be all the distances will not be measured from pole. The distances will be measured from optical center, because in lens we are having optical center instead of pole. So point number 1, it says all the distances will be measured from the optical center. Incident ray will be taken from left to right. Distances towards the right will be considered as positive, towards the left considered as negative, height above the principal axis will be considered as positive, and height below the principal axis will be considered as negative. No changes required. Only you need to replace pole with the optical center, and the sign convention for the spherical lens is done. Now, talking about the lens formula, we studied about the lens formula, spherical mirror formula, which was giving the relation between u, v and f, that is object distance, image distance and focal length. Similarly, the lens formula also gave us the relation between u, v and f. But there is only one change required. Instead of using positive sign, I will be putting a negative sign in between, and the formula becomes 1 by v minus 1 by u is equals to 1 by f, and the magnification formula, that is going to be n equals to height of image by height of object, that is equal to image distance by object distance without a negative sign. In the mirror, it was a negative sign placed where after, before v and u. It was already given. It was minus v by u. Here we are not required to put a negative sign. So that is the formula for the magnification. What else? Let's talk about the last concept of this chapter, that is the power of the lens. So power of the lens is defined by the ability of the lens to converge it, like how much it can converge the light ray or diverge the light ray. This is what the power of the lens is, or in a simple language or in a one liner or objective type, this is how it appears. The power of lens is nothing but the reciprocal of the focal length, and this is how it seems. Like the focal length is equal to 1 by focal length, but you need to keep one thing in mind, it has to be in meters. But if the focal length is given in centimeter, just change your formula in a bit. You can write it as 100 by focal length in centimeters, or otherwise you will have to convert the focal length from centimeter to meter. Then you can use this formula. I hope you got this concept. Now, what if I'm going to combine few lenses all together? What is going to be happen? What kind of power is going to be? So it's a very simple thing. I need to evaluate the individual powers of those lenses. Once I get it, do the algebraic sum. You just need to add them with their signs, whatever you are getting, a positive or negative depending on the value of power and focal length. On the basis of that, you need to put the value of power, that is P equal to P1 plus P2 plus P3 and so on, whatever number of lenses you are going to use. Let's do one thing. Let's solve some numericals and get the value to understand this. So first of all, we are provided with a 2 centimeter tall object is placed perpendicular to the principal axis of convex lens. Now, one by one, we are going to solve this. We are provided with a convex lens. The object distance given, object height given to us, that is 2 centimeter, of a focal length 10 centimeter. So the focal length given as 10 centimeter. Remember one thing, where the focus of convex lens occurred, was it on the right side or left side? So imagine this is our convex lens. So when the ray of light coming parallel, to the principal axis, it converges, and this is the point where I will be obtaining my focal length, which is on the right side of the lens. So I will be considering it as positive. Now we are given with the distance of the object from the lens is 15 centimeter. So the object distance, that is u, given as 15 centimeter, and object distance will always will be negative and will be placed on the left side of the lens. Now I need to calculate the value of position of the image, nature of the image, size of the image. This is what I need to calculate. Also, they asked me to find out the value of magnification. Now I understood what exactly given to us, what I need to find. Let's put the value and do it. First of all, I'm going to apply lens formula, that is 1 upon v minus 1 upon u, that is 1 upon focal length. 1 upon v, I'm not familiar with, negative sign. Object distance given, that is negative 15, so I'm going to put the value. Focal length given as positive 10, so I'm going to put positive 10. minus minus will become plus, and this plus 1 by 15 will go on the other side, and positive 1 by 15 is going to be negative 1 by 15. So 1 upon V, by taking LCM, I will be getting 30. So this is 3 minus 2, and the value of 1 by V is 1 by 30. Let's do the reciprocal, and I will be getting the value of V as 30 centimeter with a positive sign, which means the image will be forming on the right side. That is the only reason the image distance will be positive. Now, moving ahead, height of object given, I will be using the formula for the, or the relation, the relation between HI by HO, that is equals to V by U. So height of image, I need to calculate height of image given as 2, value of image distance given as 30, object distance is negative 15. Now solve this. 15 and 30 will be getting cancelled out. So HI is equals to 2 will be going on the other side. This is going to be negative 4 centimeter. Part number C, that is magnification. To solve this, you can either go with HI upon HO, or you can even do V upon U. In both ways, you would be getting your answer. So magnification, height of image is nothing but minus 4, height of object given as 2, and the magnification that I have got, that is negative 2. And because the magnification value is negative, which means the image is real and inverted. If the value of magnification is positive, that will be virtual and direct, because since we have got the negative value, it will be real and inverted. Moving ahead to the next question, it says, now we have a concave lens which has a focal length of 15 centimeter, and focal length for the concave lens will be considered as negative. So I'm writing as negative 15. I'm writing negative 15 value. At what distance should an object from the lens be placed so that it forms an image 10 centimeter from the lens? So it says the value of V is negative 10 centimeter, and the value of U I need to calculate. Also find the magnification. This is what the image in the concave lens generally occur on the left side. So I have kept with a negative sign. So I'm in the given data I have put all the correct values. I only need to solve this. So let's do it. Part A, 1 by V minus 1 by U, that is equals to 1 by F. The value of V given as negative 10 minus 1 by U, and that is negative 15. So I'm going to take negative 1 by U on the other side and negative 1 by 15 on this side. So what will be I getting? 1 upon U, that is equals to minus 1 by 10 plus 1 by 15. Let's take LCM. I will be getting 30. This is negative 3 plus 2. So 1 by U, that is negative 1 by 30, and the value of U is nothing but minus 30 centimeter. So to get the value or to get the image at 10 centimeter, if the concave lens is of 15 centimeter, the object should be placed at 30 centimeter. Talking about the magnification, so magnification formula is nothing but V upon U. So the V value given as negative 10, the value of U I have just obtained as minus 30. So the magnification is 1 by 3. Done. In concave lens, in both the cases, whatever formation of image we have seen, if the object is at infinity, image will be at focus point size. That means the magnification will be less than 1. Even in the second case, the image size was diminished or smaller than the object, which means the magnification value will again be less than 1. And this is what I have got. 1 by 3, which is less than 1, and it clearly states that the image size will be smaller. Moving ahead to the other question.
Now again we are provided with the concave lens of focal length 25 centimeter, convex lens of focal length 20 centimeter. Now we are provided with two different lenses. So concave lens, so I am writing it as f1, considering lens 1 whose focal length given as 25 centimeter. Since this is a concave lens, it will be considered with a negative sign. For a convex lens, it will be considered with a positive sign and the value given as 20 centimeter. Placed in contact with each other, so both the lenses are capped along each other. So this is concave lens and this is convex lens. They capped along with each other side by side. What is the power of this combination? So they are asking about the power of the combination. Also calculate the focal length of the combination. Quite easy. We know the formula for to calculate power. So I'm going to calculate individual powers. So power 1 for the concave lens, this is going to be 100 by focal length 1, that is 100 by negative 25, which is nothing but minus 4 diopter. The unit for power is nothing but diopter, represented by capital D. Similarly, power 2, that is equal to 100 by focal length 2. This is going to be 100 divided by 20, which is nothing but 5 diopter. The combination power is going to be P1 plus P2. Let's put the value. So negative 4 plus 5, and power for the combination will be nothing but 1 diopter. What I just did, calculate individual powers, add them, get the value. Now I need to calculate the focal length for the combination. So I will be using the power for the combination only. So in part B, power of combination, that is equal to 1 by focal length of the combination. So focal length of combination, that is 1 by 1. So this is going to be 1 meter. Because I'm considering 1 by focal length, that means by default it has to be in meters. If I'm going to consider 100 by focal length, the answer will be 100 centimeters. So in both ways you can solve and get the value. So that's your answer. I hope you got the concept of the combination of cell, how to get the power and focal length. Again, we are provided with the combination numerical. So a convex lens of focal length 20 centimeter is given. So let's write the given value. So the focal length of the convex lens, that is 20 centimeter, and in contact with concave lens whose focal length is 10 centimeter with a negative sign, find the focal length and power of the combination. So power of combination, focal length of combination. So solve this. So in first case, power for 1, that is 100 by focal length 1. So that is 100 by 20, which is going to be 5 diopter. Similarly, for power 2, that is 100 by f2, which is going to be 100 divided by minus 10, which will be negative 10 diopter. And power for the combination, how much it will be? 5 plus 10 or 5 minus 10? Correct. It will be 5 minus 10. So power for the combination is nothing but 5 diopter. Absolutely right answer, guys. Absolutely right answer. But I also need to calculate the value of focal length for the combination. So power of combination, that is equal to 100 by focal length. Let's try for the to get the value in centimeter. In centimeter. So focal length for the combination, that is equals to 100 by negative 5. So which is going to be, this is 20. So this will be negative 20 centimeter. Now this is your answer. That's how you solve numericals based on the power of combination of lengths. Now, important segment, that is PYQs. What kind of question been asked in the previous years in the board examination? Let's have a look and let's try. Let me see. Just write down in the comment box how many questions you made right, how many questions you have attempted or not attempted. separately, so that we will be analyzing our preparation on the basis of whatever concept we have studied so far. So moving ahead to the very first question, it says an object is placed at a distance of 30 centimeter from the reflecting surface of a concave mirror of radius of curvature 40 centimeter. The image formed is. To get this, I need to write the given values. The object is placed at 30 centimeter. The radius of curvature for the concave mirror given as negative 40 centimeter, which means the focal length will be negative 30 centimeter. If the focal length is 30, center of curvature is 40, object placed between C and F. Object placed between C and F. Now remember this case. Object is between C and F. Now remember the image. Image will be beyond C. Size. What about size? Enlarged. Nature, real, and inverted. Now look at the options. We are provided with virtual and magnified, virtual and diminished. Virtual and magnified, real and magnified, real and diminished. So we are getting enlarged value, that means magnified. So option number C will be the right answer. So this is the reason, the formation of images and the rules for the formation of images are highly required, necessary, very, very important for you, because such kind of question already been asked in the previous years. Moving ahead for the next question, which says students want to obtain an erect image of an object using a concave mirror of 10 centimeter focal length. So it is a concave mirror. So this is my concave mirror. I'm just drawing the principal axis. This is pole, this is focus, and to obtain the erect image, I need an erect image, and erect image can only be obtained when the object is capped between pole and focus. So I need to place the object over here to get an image on the either side, whose nature will be virtual and direct. So what exactly they are asking? What will be the distance of the object from the mirror? Less than 10 centimeter of focal length? 10 centimeter? Between 10 and 20? More than 20? I don't think this will be taking more than 10 seconds to make it right. So the object should be placed less than 10 centimeter, which is less than its focal length, and we will be getting the virtual and erect value. Next question says the image of an object placed in front of a concave mirror of focal length 15 centimeter is of the same size. The distance between object and image is same size. The only and only case where the image will be forming at the same place or of the same size, where the object distance and image distance will be equal to each other, that is center of curvature. So the object placed at center of curvature, image obtained at center of curvature, same size, same distance. Distance between object and image. So if this is your object, this is your image, no distance required. A, B, C, D. Answer is D, 0. Correct answer. So this question been asked in 2022. Moving ahead to the next question. At what distance from a convex lens should an object be placed to get an image of the same size as that of the object on the screen? Really? They again ask the same question like just after a year. So where I need to put the image? At center of curvature. So let's have a look. Beyond twice the focal length. That means beyond center of curvature. At principal focus. No. Twice the focal length at center of curvature. The eye should be, give a spark to see this option. Let's have a look to the other one. Between optical center and principal focus. Not at all. So the option number C is the right answer. 2023 they asked like when an object is placed beyond 2f of a convex lens, the nature of the image formed is. Really? Beyond center of curvature, we know that. We earlier discussed about it. Beyond 2f, beyond 2f. Let's have a look. So if we go beyond 2f, image will be between f and 2f. It will be diminished, real and inverted. Amazingly, we would be able to solve this question. So the image will be real, inverted, diminished. Done. Real, inverted, diminished. Virtual cannot be made. Real, inverted, magnified. Magnified cannot be, considered, because once you are moving towards the optical center after center of curvature, then the image gets magnified. So magnified will not be the solution. So all three options are correct. The first option is absolutely right. Moving ahead to the another question. Last year this question been asked in the previous year. An object of height 4 centimeter, okay, is placed at a distance 30 centimeter from the optical center of convex lens of focal length 20 centimeter. Now they ask some serious thing. Okay, let's do it. What are the given values given to us? The object of height, that means the height of the object given to us, that is 4 centimeter. Placed at a distance 30 centimeter, that means the object distance given as negative 30 centimeter from the optical center of convex lens of focal length 20. Because it is a convex lens, the focal length will be considered as positive. Using lens formula, the distance between image from the optical center. They asked me to find the image distance. Okay, do it. So 1 by V minus 1 by U, that is equals to 1 by focal length. So 1 by V I need to calculate. Object distance already given, that is negative 30, and the focal length given as 20. So minus minus is plus. If I'm going to take it on the other side, this is going to be negative. So 1 by 20 minus 1 by 30. Let's take the LCM. I will be getting 60. So this is 3 minus 2. So 1 by V will be equals to 1 by 60, and the value of V is coming out as plus 60 centimeter. That is the value of image distance from the optical center. Second, height of the image formed. Okay. So we know the relation HI upon HO, that is equals to V by U. So the height of image is unknown. Height of object given as 4. Image distance 60. Object distance minus 30. Let's cancel out. You will be getting 2. And the height of image that we have got, that is minus 8 centimeter. Which clearly states the image will also be real inverted, because the height came out as negative. That means it is below the principal axis, parallel to the negative y-axis. Done. Okay. So, okay, one last question. The value of magnification M for lens is negative 2. Using Cartesian sign convention and considering that object is placed at distance 20 centimeter from the optical center of this lens, the nature of the image formed is, amazingly, in the concave lens do not have this capability to produce any real image, because the magnification given is negative 2. So this cannot be possible. We are provided with M equals to negative 2, and it gives the, considering object is placed at 20 centimeter from the optical center, nature of the image formed. Option number 1. Okay, let's do one thing. I'm going to write it here. Since magnification is negative, the nature will be real and inverted, which can only and only possible if I'm going to use convex lens. Concave lens do not have this capability. The size of the image compared to the size of the object, this is what I need to calculate. So we are given with magnification equals to minus 2, that is equals to HI by HO. So height of image is equals to 2 times of the height of object. So the size of image compared to the size of object, so I can say that it is twice as of object. Height of image is twice of the size of the object. Talking about the position of image, position of image, that means I need to calculate the value of V. For that, I am going to use HI by HO, that is equals to V by U. Height of image and height of object given as -2, that is equals to value of V, which is unknown, and the value of U given as -20, and the value of V is finally coming out on by doing the cross multiplication as 40 centimeter. And the last, sine of the height of image. Of course, the sine of height of image is coming out as negative. No question required. Already, it's already there. The height of object will always be positive, and the height of image in that case will be coming out as negative. So negative. So in this chapter, what exactly we have covered? We discussed about the reflection, where we covered the reflection through the plane mirror, spherical mirrors, and the entire study about the spherical mirrors, which includes types, which includes formation of images, which includes mirror formula, then we switched to refraction of light, then we moved to spherical lens, which include types, again formation of images, what last? Lens formula, and magnification. It comes under this category: lens, formula, and power of lens. These were the major topic that we have covered. Apart from that, we did so many numericals based on above category, and at last we did PYQs. What kind of questions been asked in the previous year? So that was the entire chapter, or the one shot of this wonderful chapter, that is light, reflection and refraction. You need to revise the concept. I would highly recommend not to revise too much of theory, rather write down the theoretical question, practice accordingly, and apart from that, solve as many numericals as you can, and this is how you would be able to crack this chapter, and you will be getting 100% marks. I would also request you to solve the DPP or the practice sheet, what you are going to get our PW Foundation English channel on the free batches, and solve them, conclude them, and achieve as many marks as possible. So thank you so much. This is your teacher Vikas Agrawal. Thank you so much, guys. Have a great day ahead.